So what's kind of cool is that we can use reference angles to find the values of the following. So we had the unit circle before, which was great and handy, but now we can actually use our understanding of reference angles and then knowing if it's x, y, and if it's positive or negative to find the values of these. So the first thing that I always do when I'm asked to find the exact values is, first of all, actually before I even drew this, I draw my table of values. So let's draw those tables of values. So we've got 0, we have 30 degrees, which is pi over 6. We have 45 degrees, which is pi over 4. And then we have 60 degrees, which is pi over 3. And then 90 degrees, which is pi over 2. So we've got those values. And then we've got sine, cosine, tangent. So using that trick that we learned on the last slide, you can fill this in pretty quickly. I'll fill it in for you. So this is 0, 1/2, root 2 over 2, root 3 over 2, and 1. And then I get 1, root 3 over 2, root 2 over 2, 1/2, and 0. And then 0, root 3 over 3, 1, root 3, and undefined. So if I go to look at these values, so 7, sine of 7 pi, so let's see where 7 pi would be. All right, I always draw this because this always helps me. So 7 pi, so there's 1 pi, 2, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So I land right there. So on that point on the unit circle, sine is the y value. So the y value at this point is going to be 0. The cotangent of 11 pi over 2. Okay, so let's look. So 11 pi over 2. So here's pi 0. Here's pi over 2. Here's pi. Here's 3 pi over 2. Okay, so 11 pi over 2 is equal to, so how many times does 2 go into 11? 5 times, and we have 1 left over. So that's equal to 5 pi plus, sorry. Let's rewrite this so it's a little bit simpler. So this is going to be equal to, so 2 goes into 11 5 times. So this I could rewrite as 5 pi plus 1 pi over 2 because I would have 1 left over. 2 goes into 11 5 times with a remainder of 1. So this helps me to be able to figure out where this is on the unit circle. So I'm going to go 5 pi. So 1, 2, 3, 4, 5. And then I'm going to go 1 more pi over 2. So that's going to land me right here. So cotangent is, instead of it being y over x like tangent, it's going to be x over y. And if I do x over y, so at this point, we've got a coordinate point of 0 and -1. So we get 0 divided by -1, which is 0. The tangent of -3 pi. So -3 pi is going to be going backwards. So 1 pi, 2 pi, 3 pi. So I end up right here. There's -3 pi. So that reference angle is going to be 0 degrees. Tangent of 0 degrees is 0, or you could again do the coordinate point. So this has a coordinate point of 1, 0. Tangent is y over x, so 0 divided by 1 is 0. Okay, now we can also use these to figure out these other values. I'm going to erase that so I have a little more space right here. So the sine of 30 degrees minus the cosine of 40 degrees, 5 degrees. So the sine of 30 degrees is 1/2 minus the cosine of 45 degrees is root 2 over 2. This is where this chart comes in handy. So when you go to simplify these, this is just, if I wrote this as one fraction, common denominator is 2, so that's the number that goes on the bottom. And then you just subtract the numerator, which you can't really do anything other than writing it as 1 minus root 2. So it just stays that ugliness. The secant of 30 degrees. So the secant of 30 degrees is going to be the reciprocal of the cosine of 30 degrees. So the cosine of 30 degrees is root 3 over 2, so the reciprocal of that is 2 over root 3. The cotangent of 45 degrees is going to be the reciprocal of the tangent of 45 degrees. The tangent of 45 degrees is 1, the reciprocal is also 1. So when I do that, I get 2 over root 3, but I need to have a common denominator, or I need to rationalize the denominator so I don't have a radical there. So we multiply by root 3 over 3, which gives me 2 root 3 over 3.